Hello everyone, in this lesson, we'll delve into the configuration of I/O signals for FANUC industrial robots. Mastery of I/O signal configuration is a key step to ensure smooth communication between robots and peripheral devices. I hope that through this lesson, you can proficiently grasp the configuration methods for FANUC robot I/O signals. First, let's learn about the CRMA15 and the CRMA16 signal interfaces. Communication methods between FANUC industrial robots and peripheral industrial control devices include bus communication, hardware, process I/O boards, CRMA15 and CRMA16 interface connections, etc. Pros I/O boards include the MA and MB boards in the A cabinet of the R30IB control cabinet, and the GA and GB boards in the B cabinet of the R30IB control cabinet. The mid cabinet of the R30IB control cabinet includes CRMA15 and CRMA16 signal interfaces. The wiring and signal configuration of the above I/O types are explained below. The wiring schematic for process I/O, the figure below is the MA and MB boards. In the A cabinet of the R30IB control cabinet, we can see that the process I/O board MA is connected to the main board via an I/O link cable, and the GD1A, GD1B interfaces, and then connected to peripheral devices via a peripheral equipment connection cable. The following diagram shows the process I/O wiring schematic for the GA and GB boards in the B cabinet of the R30IB control cabinet. We can see that the process I/O board is connected to the main board via an I/O link cable and the GDIA, GDIB interfaces, and then connected to the peripheral devices via a peripheral equipment connection cable. Following the B in A out principle, connecting the GD1A port on the MA board to the GD1B port of the MA board allows daisy chaining of additional MB boards. The following diagram shows the CRMA15 and the CRMA16 in the main cabinet of the R30IB control cabinet. Next, please answer this question. Which of the following is not a main communication method between FANUC industrial robots and the peripheral industrial control devices? A. Bus communication. B. Hardware process I/O boards. C. Radio communication. D. CRMA15 and CRMA16 interface connections. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's continue. Next, we'll focus on learning about the CRMA15 and the CRMA16 signal interfaces, including CRMA15, CRMA15 hardware, pin definitions of CRMA15, CRMN16 hardware and allocation cases for FANUC robot DIDO communication with peripheral device signals. The diagram below shows the panel plug of the compact control cabinet CRMN15 and CRMN16. The diagram below shows the pin signal definitions for the CRMN15, CRMN16 panel. Next, please answer this question. Which signal interfaces are definitely included in the main cabinet of the R30IB control cabinet? A. CRMA F2A CRMA 52B. B. CRMA 15 CRMA 16. C. CRMA 5A CRMA 5B. D. All of all. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, let's continue. In practical use, data cables are laid out from the CRMN15 and CRMN16 panel plug. Connect the data cables to the CRMN15, CRMN16 I/O terminal block conversion board. Then through the terminal block, the data cables are connected to the signals of peripheral devices as shown in the diagram. The diagram below shows the wiring terminal definitions for the CRMN15 I/O terminal block conversion board. This diagram is an example of electrical diagram for the wiring terminals of the CRMN15 I/O terminal block conversion board, which clearly shows examples of peripheral devices connected to DIDO and common terminals. The diagram below shows the wiring terminal definitions for the CRMN16 I/O terminal block conversion board. The corresponding diagram is an example of the electrical diagram for the wiring terminals of the CRMN16 I/O terminal block conversion board, which also clearly show examples of peripheral devices connected to DIDO and common terminals. Okay, everyone. After learning about the hardware definitions and the electrical signal connection examples for the CRMN15, CRMN16 signal pins, we'll now study signal allocation. The purpose of signal allocation is to establish the relationship between the robot's software host and the communication devices. In other words, after completing the wiring of the CRMN15, CRMN16 signal pins, software settings are still required, namely the signal allocation. Next, we'll use the allocation of digital I/O signals as an example to illustrate how to allocate I/O points. Press the I/O key to enter the setting interface as shown below. Press F2 allocation to enter the digital signal allocation interface as shown below. The first column is the range of software ports. The second column is the rack number, representing the type of communication device. Specific values. The rack number for process I/O is 0. The rack number for CRMN15, 16 is 48, and the rack number for Modbus TCP communication is 96. A complete description of rack number is shown in this table below. Next, please answer this question. What operation is required after completing the hardwiring of CRMN 15, CRMN 16 signal pins? A. Restart the robot. B. Forced simulation. C. Software signal allocation. D. Power check. I will give you 5 seconds to think and will show the answer after 5 seconds. The answer to this question is C. Did everyone choose the right answer? Okay, let's continue. The third column is the slot number, which refers to the number of the I/O module constituting the rack. Specific values. The slot numbers for process I/O are 1, 2, 3, with the first board being 1, the second board being 2, and so on. In this diagram, the slot number for CRMN 15, 16 is 1. The slot number for Modbus TCP communication is also 1. The fourth column is the start point, which corresponds to the starting pin address of the I/O device for the software port. It's used to assign physical numbers to logic numbers for signal line mapping. In this diagram, DO1 to DO64 are allocated to Modbus TCP, and DO65 to DO120E are allocated to the main board of the R30IB mate. The fifth column is the status of the allocation setting, where active means activated, UNASG means undefined, PAND means takes effect after restart, and invalid means invalid. Press F3 in-out to switch between signal input and digital output. The allocation steps for digital inputs are the same as those for digital outputs. After performing I/O allocation operations, the FANUC industrial robot must be restarted for the I/O allocation settings to take effect. Next, please answer this question. When allocating I/O points for FANUC robots, which rack number corresponds to digital input-output signals? A. 0, B. 48, C. 96, D. All of the above. I will give you 5 seconds to think, and will show the answer after 5 seconds. The answer to this question is B. Did everyone choose the right answer? Okay, next, we'll discuss the allocation of group signals. Step 1. Press the menu button, select File I/O and choose 5 groups on the tap interface. Step 2. Press F2 Allocation to enter the group output GO allocation interface as shown below. The following items need to be filled in this interface. A. Rack, type of I/O communication device. B. Slot, number of I/O modules. C. Start point, starting signal bit corresponding to the I/O number. D. Number of points, number of signal allocated to a group. Take attention, the number of signals allocated to a group can be to 16. The following settings are allocate 4 digital outputs DO as a group, as shown when DO1 and DO2 are on and DO3 and DO4 are off. The value of GO1 is 3 when DO2 and DO3 are on and DO1 and DO4 are off. The value of GO1 is 6. Okay everyone, next we will learn about out signals and forced simulation. For output signals, forced output can be performed directly. The operation steps are press, manual, then we can see I/O. Click digital I/O. Enter the interface as shown in the finger. Press in/out to switch to the DO overview screen. Move the cursor to select the DO signal status bar that needs forced output, and then click on/off below to force the output. Simulation function for input and output signals. For output signals, forced output can be performed directly. For input signals, a simulation function is generally used. Output signals can be used simulated. After entering the interface shown below, move the cursor to select the DIDO column to be simulated. Click Simulate below, and the signal status will change from U to S, allowing simulation of on or off operations for the signal. One simulation image for input signal. 2. Simulation image for DO output signal. Everyone, in this lesson, we've deeply studied the configuration methods for FANUC robot I/O signals, including I/O communication methods, CRMAIN15 and CRMAIN16 signal interfaces, I/O signal allocation and settings, as well as output signals and forced simulation. I hope that you can master this knowledge proficiently to lay a solid foundation for subsequent courses. Thank you all. That's all for this lesson. See you next time.